Very good morning, students. Welcome back to our online classes, and we are having our practical experiment today through the online medium, right? So our aim of the experiment today is to find the focal length of a convex mirror, okay? And by with the help of a convex lens, to find the focal length of a convex mirror using a convex lens. First of all, I want to ask you that why we cannot find out the convex mirror, focal length of convex mirror without the help of convex lens, because the convex mirror produces virtual images. Okay? Virtual images means the focal length, the center of curvature and the images are always produced inside the mirror. Clear? ये जो मिरर है इसके भीतर आप लोगों का सब कुछ प्रोड्यूस होता है, तो हम लोग मिरर के अंदर घुसकर ये सब कैलकुलेट नहीं कर सकते. ठीक है? सो वी हैव टू take the help of a convex lens so that we can find out the center of curvature, position of the center of curvature of this mirror with the help of convex lens. And as we will find out the position of the mirror, then we will find out the center of curvature. From that we will be finding out the radius of curvature of this mirror, and we know the focal length is equal to radius of curvature by 2. So if we find out the radius of curvature of this mirror, then we will be finding out the focal length of this mirror. Clear? और radius of curvature को पाने के लिए हमको क्या चाहिए? We have to find out the position of the center of curvature. We have to find out the position of the mirror. After that, by subtracting those two values, position of the center of curvature minus position of the mirror, then we will be finding out the radius of curvature. ठीक है? So how to find out that? First of all, we have to put an object needle here. What is this? This is an object needle. Whenever we put an object needle, after that a lens and followed by the mirror. ठीक है? When the setup is like this, what happens? The light rays emerging from out of the tip of the object needle is converged by the lens. Okay? This conversion, what happens after this conversion? The converged ray are parallel to the plane of the surface of the mirror. Okay? Clear? Because when we place the object needle here before the lens followed by a mirror, okay, what happens? The light rays coming from the object needle are converged through the lens. Okay? And as we are adjusting the object needle, okay, adjusting the position of the object needle so that the conversion of these light rays are, when they are incident upon the mirror, they are incidenting on the at 90-degree angle. Okay? Whenever these rays incident through 90 degree to the plane of the mirror, what happens? We already know, if a mirror is there and the incident rays are perpendicular to the plane of the mirror, what happens? They are reflected back. Okay? And this incident ray which is perpendicular, if we extend virtually the lines, if we extend the lines virtually, then they will be meeting at center of curvature. You understood why we are converging these rays emerging out from the tip of the object needle through the perpendicular to the plane of the mirror? Because if these will be perpendicular, then these lines will be virtually meeting at the center of curvature, and the image which is to be produced here, now the image is produced at the point O, okay, just above the object needle. Here the image is produced just above the object needle. Why? Due to the presence of the mirror. Because the light rays emerging from the tip of the needle converged by the lens and making 90 degree to the plane of the mirror, they are reflected back. Because those light rays who are perpendicular to the plane of the mirror always reflected back in the same manner. Okay? And these lines who are perpendicular, they are supposed to be meeting at center of curvature. So image to be produced at center of curvature, but due to the presence of mirror, what happens? the mirror producing an image at the tip of at the same position as the object. ठीक है, so from here what you get, इमेज का पोजीशन हमको पता चल गया, मतलब मिरर का पोजीशन हमको पता चल गया, लेंस का पोजीशन भी हमको पता चल गया एंड ऑब्जेक्ट का पोजीशन को भी हमने पता कर लिया. सो नाउ कीपिंग दीज टू पोजीशंस ऑफ द ऑब्जेक्ट नीडल एंड द लेंस कांस्टेंट. ठीक है, अगर इन दोनों ऑब्जेक्ट नीडल और लेंस का पोजीशन को अगर हम कांस्टेंट रखेंगे और अभी मिरर को हटा देंगे. ठीक है, इफ वी रिमूव द मिरर फ्रॉम these three setup, what happens, the image produced here will be now produced at center of curvature. The image, why this image is produced here? Due to the presence of mirror, because the mirror was obstructing the light rays were coming perpendicular to its plane. It was obstructing and reflecting back to this point. ठीक है, so image is produced here, but actually the image to be produced at the center of curvature. ठीक है, तो यहाँ पर जब हम मिरर को हटा देंगे, what happens whenever we remove the mirror from this setup, what happens, the light rays emerging out from the tip of the needle will be directly joining here and the image is produced at the center of curvature. अच्छा, अब सेंटर ऑफ कर्वेचर पर हमको इमेज मिल गया, लेकिन इस इमेज को कैप्चर कैसे करेंगे? टू कैप्चर दिस इमेज वी नीड an image needle, another needle we need. This is an object needle and another needle, that is image needle, we are placing other side of the lens. ठीक है, इमेज यहाँ पर बन रहा है, तो हम क्या करेंगे, we will displace this image needle, we will displace image needle pro and throw. ठीक है, मतलब उसको आगे थोड़ा लेंगे, फिर उसको पीछे थोड़ा लेंगे एंड इसको एडजस्ट करेंगे. where the image needle will be coinciding with the image formed by this lens, that point will be your center of curvature. So we have to note down the position of the image needle, then we will be getting the position of the center of curvature. Before we drawing the mirror, we also have got the position of the mirror. So from the position of the mirror, it is the position of the mirror, it is center of curvature position. To if we minus these two magnitudes, ठीक है, और the values, what happens, we will be getting the radius of curvature. ठीक है, once we get the radius of curvature, we will be getting the focal length by dividing 2 in the radius of curvature. That is the whole concept behind it. And the ray diagram is very much important that you have to focus on, right? क्योंकि यहाँ पर convex lens को हम क्यों यूज कर रहे हैं? Because the convex mirror will be producing virtual images and the focal focus and the center of curvature are produced inside the mirror. हम मिरर के अंदर घुसकर वहाँ उसका निकाल नहीं सकते कितना उसका डिस्टेंस है. ठीक है, so we have to get an alternative way so that we can find the position of the center of curvature. ठीक है, so we have placed lens at such a position that the emerging rays are meeting at the center of curvature of the mirror. ठीक है, तो मिरर को हम हटा लेंगे तो सेंटर ऑफ कर्वेचर पर आपका इमेज फॉर्मेशन हो गया. इस इमेज को कैप्चर करेंगे इमेज नीडल के प्लेसमेंट से. नाउ वी विल बी गेटिंग द रेडियस ऑफ कर्वेचर. फ्रॉम दैट रेडियस ऑफ कर्वेचर वी विल बी फाइंडिंग आउट द वैल्यू ऑफ फोकल लेंथ, राइट? सो द apparatus required here are first of all meter scale and one optical bench, then 4 uprights, 4 in numbers, convex mirror, one convex mirror, one convex lens, one mirror holder, two mirror holders, lens holder, sorry, one mirror holder and one lens holder and 2 optical needles, right? So these are to be proceeded now. You will be observing how the experiment is done. Okay, now coming to our experimental setup, right? In the experimental setup, we have to first discuss what are the apparatus required for this experiment, right? So here, as you see, here is an optical bench, right? This is the first experimental apparatus we require. This is an optical bench. These are called uprights. Like these are the structure are called uprights. So 4 uprights we need, and two optical needles. These needles are called optical needles. So two optical needles we need. This will be used as object needle and this will be used as image needle, right? And upon these two uprights, there is a lens holder and another one is image holder, right? One lens holder, one image holder, 4 uprights, one optical bench and one convex lens and another one is convex mirror, right? Apart from that, we will be requiring this meter scale to measure the distances, right? So clear, these are the apparatus required for this experiment. Now to start this experiment, we have to set up the optical object needle in front of the convex lens followed by the convex mirror, right? Now where this object needle to be placed, who can say? The optical needle to be placed in between the f and 2f of this convex lens, because if we place this optical needle between the focal length f focus and 2f, what happens? The image produced is real in nature, inverted, and the nature will be enlarged. ठीक है, हमको एक enlarged image चाहिए, so that और real भी होना चाहिए, so that we can capture that. Okay, and so that we have to put this optical needle or the object needle in front of the lens at a distance between f and 2f. ठीक है, तो f and 2f के भीतर हम क्या करेंगे? 1.5f पर रख लेंगे, because 1.5f is exactly between f and 2f, right? So how to find out the focal length of this lens? If we don't have the focal length of this lens, then we cannot find 1.5f, right? So first work we have here to find out the focal length of this given lens, right? Let's see how to find out the focal length of this lens, roughly calculated focal length. ठीक है, क्योंकि we cannot find out the exact value of focal length, but we can by using a procedure we can find out the roughly calculated focal length here. If we once find out the focal length of the lens, then we will be placing our object needle at a position of 1.5f. Clear? One second. Now we place the meter scale here upon the bench, right? Then we will be placing this plain paper as a screen, right? And after that, what happens? We are placing the convex lens in front of this screen and slightly move forward and backward, so that we can focus the distant object. As I have taken the window as the distant object, so you can see the distant object is focused on the plane of the paper. है कि नहीं? देखो देखो, जैसे whenever I moving far away the lens, the image is fading, but whenever I moving closer to it, at some point the image is very clear, right? So this is our focal length of this mirror, and you can see the focal length of this mirror is on the scale is 16 centimeter. You can see here the roughly calculated focal length is around 16 centimeter of this lens. So we have got the focal length of this lens, right? So now if we place, now see, if we place the lens at a point of 65 centimeter, right? Now you can see the position of this lens is 65, right? 65 पर इसको रख दिया गया. Now you can calculate that as this the focal length of this lens is 16, so 1.5 into 16 will be, let me calculate, 1.5 into 16 will be 24. ठीक है, 24 centimeter, right? So the lens position is at 65 centimeter. The object needle to be placed at 65 centimeter minus 24 centimeter, which will be equal to 41 centimeter. right? Because this object needle to be placed 24 centimeter away from the lens. So our object needle to be placed at 41 centimeter. So let's place this object needle at 41 centimeter. Here you can see the object needle is adjusted to 41 centimeter. This is 40, this is 41, right? Exactly at 41 centimeter, right? Now what to do? Now we have to coincide or the placement, right? Coincide the object needle to the image produced by the mirror, right? Now see, let me set up the needle. So now the setup is completed, right? The object is placed at 41 centimeter, right? Just at the distance of 1.5 f. So the lens is placed at 65 centimeter, right? The lens is at 65 centimeter, object needle is placed at 41 centimeter, right? Now see, the image, mirror is placed at 75 centimeter, right? See, 65, 75. Object needle 41, 65 lens, and 75 is the mirror, right? Now let's see. The object needle, whenever placed at 41 centimeter, what happens? Just look through the glass. Focus on the glass. You can observe right? See the points. This object needle is, there is an image in the lens due to this object needle. But what happens when we move left and right to this object needle? What happens? The needles are not coinciding each other, right? At the middle, the needles are coinciding each other, but whenever we are moving left, they are not coinciding. Whenever we are moving right, they are not coinciding. Are you getting? Whenever I am moving left, right, they are not coinciding. Left, not coinciding, right? Only on the middle, they are coinciding. This is called the parallax error, right? So we have to avoid this parallax error by adjusting the position of the needle, right? Now see, whenever we are moving again and again, moving forward the image needle, what happens? See, the parallax is avoided in this place. Whenever I am moving left, the upper needle also, the image needle also moving with it. Whenever right, the upper needle is also moving right. So let me avoid the parallax foolproof, then I will be showing you how that happens, right? Let me put more setup. Wait for 1 second. Now you can see the parallax is completely avoided throughout the diameter. See, the two needles, the object and the image needles, are coinciding each other throughout the diameter. There is no parallax, right? Now we have to find out the position at this setup, position of the needle. We have first placed position of the needle at 41, right? This is the observation table, right? Position of mirror 75 centimeter. Position of object after the adjustment, that is 41.1. Position of lens is at 65 centimeter. Now we have to find out the position of image after the removal of mirror. ठीक है, क्योंकि मिरर रिमूवल के बाद अगर इमेज का पोजीशन हमें मिल गया, देन दैट विल बी द सेंटर ऑफ कर्वेचर. दैट पोजीशन विल बी द सेंटर ऑफ कर्वेचर. सो द पोजीशन ऑफ द सेंटर ऑफ कर्वेचर से अगर आप पोजीशन ऑफ मिरर को माइनस कर लो तो आपका आ जाएगा रेडियस ऑफ कर्वेचर, राइट? सो सी हाउ टू डू दैट सेटअप. फर्स्ट वी हैव टू रिमूव दिस मिरर आफ्टर रिकॉर्डिंग द पोजीशन ऑफ द मिरर. ठीक है, इसे रिमूव करने से पहले मिरर का पोजीशन को आपको रिकॉर्ड करना है. ठीक है, उसके बाद हम क्या करेंगे? दिस इमेज नीडल इज टू बी प्लेस्ड समवेयर हियर, राइट? the image needle to be placed somewhere here, and now we have to find out the coincidence, right? We have to find out the coincidence of the image with this image needle, right? And after that we will be avoiding the parallax. You can see at this position we are getting a parallax. See, at this position we are getting a parallax because these two are coinciding at the middle, but whenever we moving left or moving right, the needles are not coinciding each other, right? Are you getting my point? So to avoid the parallax we have to adjust the position of this needle, right? So let me make that adjustment for you so that you will be able to understand. Now you can observe the parallax is avoided. If we move left and right, what happens? Whenever we move left and right, the parallax is avoided and the image needle is constantly moving with the pace of the object needle, right? So now the parallax is avoided. So we have to record the position of this image needle, because this position will be the position of the center of curvature, right? So position of the center of curvature is, now you can see the position of the center of curvature, position of the image after removal of mirror is 110 centimeter, right? Now we have to find out the radius of curvature. How to find out the radius of curvature? To find out the radius of curvature, we have to subtract position of mirror from position of image after removal of mirror, right? So that is 110 minus 75, that becomes 35. So our radius of curvature is measured as 35 centimeter. Then what will be the focal length? By 2, right? By 2 will be equal to 35 divided by 2 will be equal to 17.5, right? So there are 3 observations to be made, right? By differentiating the position of the mirror or changing the position of the mirror. If we place position of the mirror like 65 centimeter, position of object will be different, position of lens will be different, then position of the image after removal of the mirror also depend, and you will be getting another result of radius of curvature. Then again at 80 centimeter you place the mirror, so all of the positions of these will be changing and you will be getting another radius of curvature. Then you will be finding a focal length, here also you will be finding the focal length, then you will be taking the average focal length. If this is f1, this is f2, this is f3, so in calculation part you have to find the average focal length, that will be equal to f1 plus f2 plus f3 divided by 3. So what will be the result? That will be your finding, okay? That will be the focal length of the mirror we have used here. So hope you have understood well, students, and hope the practical session will be started very soon. Till then you just go through this video, and if you have any doubt then you can ask me. Have a nice day.